Alrighty, time for another set of free body diagrams. So here we go. Now, we have this mass right here, and the normal force is going to be perpendicular to that surface, so like this, okay? And I'm going to call that N on big M. And then we have the weight force on big M pointing down, and we have this rope tension pointing diagonally like that. So the tension of the normal should be diagonal for this. And then we have this tension force on little m pulling up, and we have the weight of little m pulling down. Now, I'm not sure if it's going to go this way or whether it's going to go back the other way. And that's something you're going to have to figure out, like when we do the numbers, which we'll do later on. Now for number 5, this is one of the trickier setups, and I love it because it's going to be our first time using Newton's third law on a problem. So check this out. I apply a force to M1, and it only acts on M1 because it's only touching M1. I have a normal on mass 1, and I have its weight. Now, M2 moves, and what we like to say casually is, oh, well, the F pushes both blocks. Technically speaking, no. F pushes M1, and M1 applies a normal force on 2 in order to push it. There's, of course, the normal force on 2 from the ground, and the weight of 2. Now, here's the interesting thing. 1 pushes 2. That implies that there is an equal and opposite force on block 1 because 2 pushes back on it. So we actually have our first instance of a third law pair in a free body diagram. So this, I'm going to put a little star here, or a little note here. This is trickier, okay? So if you just drew this free body diagram and you're thinking to yourself, oh, that sucks. Like if this is you, that's you, young student. Okay? We're going to talk about this when I get back. So don't feel sad.